Alright, in my video we will be talking about stereoisomers or naming stereoisomers and assigning CIP priority, which we'll start with CIP priority because you need to understand CIP priority to be able to name a stereoisomer. CIP priority, you assign CIP priority by first looking at the atomic mass of each atom connected to the center carbon, and then you always put the fourth, which would be the lowest mass, in the back, and then you assign priorities and go around. If it's clockwise, the three atoms that are planar with you now, if it is clockwise, it is an R stereoisomer. If it's counterclockwise, it is an S stereoisomer. And so we'll go ahead and do some examples here using this molecule. I like to use a model, and number one is easy enough because H is already in the back, or hydrogen is already in the back. So just for clarity with my molecule, I'll go ahead and highlight these. I'll do this for every one. And then bromine is the highest, iodine is the highest, bromine is second, and fluorine is third priority. And as you can see, it goes in a counterclockwise rotation, which means number one is an S stereoisomer. Second one, we'll orientate it. I always like to keep my white as a hydrogen. That's just me. So we will set it up like this. And again, we will highlight just so I am clear on which one is which. And now I just orientate it with white in the back like this. And it looks like this. And we will go ahead and assign CIP priority now. And this one, bromine again, is number one, and chlorine is 2, and CH3 is third. And this one goes clockwise, making it an R stereoisomer. Now number 3 is special because this molecule is a chiral. Only chiral molecules can be named R or S. So this one is neither. And now didn't label this. On to this one. So we like to have H be white. So set it up like this. And there, so you can see it. It is blue, green, and red. Now reorientate it. It is blue, green, and red. And now this one, our top one, is going to be oxygen, because it is first, or hydroxide, I guess. Now these two, you can see it's both carbons, but this one is CN. We'll get number 2 because N is next when that one is an H. So that's how you break it high, is you just go down the row, and then it's the same rule once you find some part difference. So this same, and difference is there, and then it's the same rule. So that applies there. And this one is clockwise, again making it an R stereoisomer. Now for our final one. This one has H coming back towards us, so we'll set it up like this. That makes this green, and this blue, and this one red. So now again you reorientate, you have red, blue, green. The hardest part, at least for me, is understanding how to take a 2D drawing into the molecule so then you can rotate it and get your correct layout. This one, our highest one, is going to be, so they all have carbons, but this one is to an O, and then C, or these are an H. Or no, sorry, this one is also to an O, but this one is another O, so it's 1, and that makes this 3. So this one is counterclockwise, making it S stereoisomer. I hope this all makes sense and that you could see enough my hands weren't covering up too much. Thank you for watching. Hope it helped.